Alrighty, this will be the second half of chapter one. We left off talking about different type of sampling. We've talked about random sampling, which is where everybody has an equal opportunity of being selected, and you give them a certain number, and then they all have an equal opportunity of being picked throughout the process. Using software is the best way to sample that. And then we get into systematic sampling, which is taking a term and then just adding however many you want. So we did one with 350 and we wanted to have 35. So 35 divided by 350 is 10. So you then take a k term, a random number between 1 and 10. We used a calculator to randomly select that, and it was 8. So then you would start off with 8, then 18, then 28, and 38, and so on to get to your 35 candidates. So the first, it's still random, but you more or less have it in strips that are random. Now we're going to go into stratified sampling. And they are obtained by dividing the population into groups according to a characteristic important to the study, and then a random sample is taken from each group. So, for example, a marketing firm samples a population by income level. The population is separated into three income categories: low income, middle income, and upper income. The marketing firm then selects some subjects from the lower group, some from the middle, and some from the upper. So in a stratified sampling, you put everybody in groups and then you randomly select some in each group so that everybody has a voice in the study. So it's not everybody has an equal opportunity, but then everyone has an equal opportunity within each group as you take some out of that. All right. Now, something very similar to stratified is the last one, which is what we call cluster sampling. All right. To select a cluster sample, the population is also divided into groups, but these groups or clusters are intact or geographic groups. Once the groups are determined, a few groups are randomly selected, and everyone in the chosen groups becomes the subject. So you could take the example from a while ago. We split them up into low income, middle income, and high income, but then I randomly select one of those groups, and then that entire group becomes my sample. So that would be a cluster. So stratified, we put them in groups and then take some out of each group. Cluster, we're still grouping them, but then we just take random groups as our study. A different example would be a school district wants to survey the opinions of elementary students. Clusters are the intact classes for each elementary school. So like, Miss Jones' class, Miss Smith's class, Miss Alexander's class, or all these different classes. Those are your clusters, and then we're going to randomly select classes out of that. So maybe we randomly select Miss Jones' class, and then they would be part of our sample. All right. Note again the main difference between stratified and cluster sampling is that although in both types of sampling, the population is divided into groups, the subjects in the groups for stratified sampling are more or less homogeneous. That is, they all have similar characteristics, while the subjects in clusters for miniature populations, that is, they vary in characteristics, as does the larger population. For example, if a researcher wants to use the freshman class at a university at the population, he or she might use a class of students in freshman orientation class as a cluster sample. If the researcher was using a stratified sample, she or he would need to divide those students of the freshman class into groups according to their major field, gender, age, etc., or other samples from each group. So note too that, like, let's say we wanted to know how everyone's liking our current president. We could separate these cluster or groups into states. And then for stratified, we would randomly just select people out of each state to have a voice in our sample, or we would just randomly select a few states. Maybe we would get a southern state and a northern state, and then that would be our sample. But within that state, there'll be a completely random different characteristics in that, right? So that would be the difference between the two. Cluster samples save the researcher's time and money, but the researcher must be aware that sometimes a cluster does not represent the population. So, for instance, if I wanted to know how the country was like in the presidency and I just chose New York State, that might not be the same result as if I was to choose Louisiana or something like that. So, cluster can be convenient because it's just one group, but could be kind of skewing the data a little bit. Now, talking about skewing data and biased data, you have stuff called convenience sampling. All right, and it's pretty much as it sounds. A convenience sample. Gotta find my pen. Are samples that consist of subjects that are available or easy to find. The sample is not random, the population is unknown, and the selection of subjects is haphazard. Results are biased or flawed, so this type of sampling is best for just pilot studies. So a lot of examples for convenient sampling is you could randomly go to a mall. I don't know, in your local city, and then you just stand at I don't know, a JC Penney, and you just randomly sample people about maybe again how they're liking their president, or maybe you just want to know what's your favorite hair color, but you're just conveniently grabbing people that just happen to come by your booth. All right, this is a convenient sample because you're just selecting people near you. There's no strategy to it. Not everyone has the same opportunity unless they go to walk by that booth. Um, so it's very convenient. So with that and with the bias that can come with it, we do have what we call sampling error. Samples are not perfect. The only perfect sample would be the entire population. So samples are not perfect representations of the populations from which they are selected. Therefore, there is always some difference in the result. And it doesn't matter how you pick the samples. You can do a random selection where everybody has an equal opportunity. But guess what? If we wanted to know the population of hairstyles, and we randomly select 20 people in our school, and 19 of them happen to be blonde headed and one ends up being a brunette, then we're going to say, oh, well, 19 out of 20, so 95% of our population are blonde headed. But in reality, it was just randomly selected that they just happen to be blonde. So even the best non-biased picking will still not be a perfect representation of the population, but a large enough sample should get us close enough. So there's 3,000 people, 20 just wouldn't be a large enough sample. But let's say if there's 3,000, we do 300. Obviously, we probably wouldn't get 290 blonde heads this time. We could get a better ratio that would get us a better idea. So to get rid of some of these sampling errors to make it more perfect, you just would want to get a larger sample size depending on our population size. Other errors that exist in samples occur for other reasons. Like again, if we are doing a cluster, it just depends on maybe we want to know how people enjoy math, and we randomly select classes, and one of them happens to be a math class. Maybe it's a calculus class where people might want to go where they actually enjoy math, so that data could be skewed versus maybe we pick an English class, like and those students there just don't really prefer math, and so that could skew the data depending on how the questions what we're asking. And we'll definitely be looking into the biased outlook as well when it comes to data. All right, so the definition for sampling error is the difference between the results obtained from a sample and the results obtained from the population from which the sample is selected. So we could do a sample to figure out what it is, but to get the population, we would have to get the result of every single person, which could cost money, a lot of time, and a lot of I suppose really wouldn't be error. You would be just mainly just time and money And then just probably just more a headache to try to get all of that data. So, a sample of full-time students indicate that 56% of the student body is female. However, the admission office states that all the full-time students, 54 are female. The difference of 2% is due to sampling error. So again, let's say there's 3,000. We select 300. We see that there's 56% are female. Then we actually have someone that's keeping up with the records that actually has all of the data for the entire 3,000. And we see that the population was actually 54. So the larger our sample, the closer we can get to our actual. If we were to only do 30, this could really be skewed. And this could be like more like 70 or maybe even 40%, depending on the people that we select. So there's always that sampling error. No sample is perfect unless it's the entire population. So then we have non-sampling errors. So maybe the sampling itself is not the error. So non-sampling errors occur when the data are obtained erroneously or the sample is biased or non-representative. A big one for this one is a convenience sample. If I go and I want to know how people like J.C. Penney, and I go out to a J.C. Penney and I put my booth right there, obviously people are going to love J.C. Penney. That's why they're going in there. Um, so that could be a biased situation. So a researcher interviews subjects who enter the mall through a particular entrance to determine the reasons for their visit. The sample is most likely not a representative of general customers for several reasons, such as the sample was likely taken at a specific time of day when not all customers to go to the mall were shopping, and the sample was taken at a particular entrance through which all customers did not enter. Therefore, all customers that go to the mall did not have an equal chance of being selected, and the difference between the sample and the population now is due to non-sampling error. All right, so now it's not so much the size of our sample, but the lack of our selection in our sample. Again, depending on the time that you're doing it, you could have done it during a work day where you're people that get are working 8 to 5 on Monday through Friday didn't get an opportunity to put their say in it. And again, if you are outside of a JCP entrance versus maybe someone at a Barnes and Noble entrance or a Sears entrance or whatever the concept might be, you'll get a different response or feedback. All right, so that's pretty much then the end of 1.3. So let's get into 1.4. And this is talking about observational versus experimental studies. Experimental studies is things that should happen, right? You have 4 colors in a marble bag. There's 4 marbles. You should get a 25% chance of getting each color. Observational, I draw 4 times, replacing each time. I get 2 reds, 1 blue, 1 green. So that tells me there's actually 50% red, and then 25% of the each, but then I completely have 0% of the other color that actually is there. So there's a big difference between experimental, things that should happen, and observational, things that actually happen. All right, so again, we'll explain the difference between the two. So again, there are 2 types of typical types of statistical studies. They are, again, observational and experimental. Observational studies, again, are researchers observe what is actually happening or what has happened in the past and draws conclusions based on the observation. So let's say I make an observation of my students who take statistics. Out of all the classes that I've taken, I've always if you take out withdrawals, I have a 100% pass rate. So in my past, y'all should all pass as well. But that's a observational study that I'm looking at. Experimentally, there's always at least 10% that fail, 20% that get a C, 30% that get a B, and then 10% that get an A. And it kind of fluctuates around that, and the numbers go up and down depending on how large the class could be, right? But those are experimental versus observational. All right, so things to kind of look at. So, some more examples on that fact. So in example A, employees are rated as more competitive and less competitive. A researcher checks resting blood pressure and finds that more competitive employees have high blood pressure. So that's observational. Literally, they're just seeing, hey, if they're competitive, they tend to have a higher blood pressure. If they're less competitive, they typically had a lower blood pressure. Again, not drawing any conclusions. That's literally just what was predicted. They asked the person, are you more competitive or less competitive? Check their blood pressure, and that's what was seen. Right. So in experimental studies, the researcher manipulates one of the variables of interest and tries to determine how the manipulation influences the other variable of interest. So, for example, that blood pressure thing, maybe it's because they take medication, right? So then we will manipulate that variable and we'll say, all right, we want a new group of people who take medication versus who doesn't. And then within that group, who's competitive, who's not competitive, and then look at that statistics. And that would be an experimental study. So, in another example here, a group of patients diagnosed with a particular condition are randomly assigned two groups. One group is given a traditional treatment that has been moderately successful. The second group is given a new treatment that shows the possibility of being more successful. The doctors providing the treatment and the patients are not told which treatment they are being given. At the end of the experiment, researchers will compare the two groups to determine if the group receiving the new treatment have better results. This would be a true experimental study in which the participants are assigned to groups randomly. Again, and what they're focused on is the certain medication that will either heal their diagnosis of their sickness. And that's what we're looking at the observation of is the experiment of the drug. That's what we're pinpointing. There might be other variables in play, but that's the one variable that's being changed or manipulated to experiment to see, is this the reason versus I'm just looking observationally on the diagnosis. Right. So in example C here, it says in one yoga class, participants were asked to hold a position known as a plank as long as possible during two classes per week for 4 weeks. In another similar class, participants were asked to increase the length of time the position was held by 15 seconds each day. During the last class of the experiment, the average length of the time of the 32 participants of the first group held a position for 4.5 minutes while the average length of time of the 37 participants of the second group who were asked to attempt to increase their time by 15 seconds each day was 6.1 minutes. The conclusion was drawn that the group who were challenged to perform better, the researcher manipulated the variable of the type of instruction given to the participant. The yoga classes then chosen were intact groups, so the researcher did not have the option of randomly assigning the class participants in each group, making this example a quasi experimental study. Quasi. Right. So again, it was just the instruction that was changed, and each class group was already formed, so they weren't randomly just plugged in there. So that's why it's a quasi, versus the last example, they were randomly chosen for the treatment. So the next set is we have what we call independent and dependent variables within this experimental stuff. The variable being manipulated is called the independent variable. So whatever is being manipulated, being changed or taken out, again, is the independent variable or the explanatory variable. The variable or variables being measured from the result of the independence, the resultant variables, are called the dependent or outcome variables. So basically, again, we are changing a drug. So that's the independent variable is the drug being changed. The dependent variable is the outcome of the drug. Did it heal the diagnosis or not? Right. So independent is the thing being manipulated. Dependent is the variable being observed. What are we observing the change of? So, some examples here. In example B, again, this was talking about the patients getting treatment or not. The independent variable there, for example B, was the treatment given to each group of participants, right? So the treatment changed in both groups. So the independent variable is the treatment given to the groups of patients. And the dependent variable would be the result. How did it heal the diagnosis that they had? So again, so the dependent variable is the response of the patients to the treatment. Which in a different aspect was the medical results. So which is the medical results? Did it fix them or not? Did it improve their diagnosis? Maybe they were just trying to, maybe it's a cancer treatment. Maybe they were lessened, their cancer went down. Maybe they were looking at their white blood cells or whatever the concept might be. Did it improve? Maybe it didn't heal them completely, but maybe at least improved. In example C, this was talking about the yoga and the plank instruction. The independent variable here is the instruction given. That was what changed. One just said do your best, where the other one said each day try to improve by 15 seconds. So the independent variable here was the instructions given. And the dependent variable here, again, is the length in time the participants are able to hold this plank. So the length of time participants hold the plank position. All right. Then from there, we have a treatment and a control group. So in an experimental study, the group for which the independent variable receives the manipulation, this is called the treatment group. This is what we're changing to see, does this treatment or this change in variable affect the outcome? And the group of which is the independent variable is not manipulated is called the control group. So if they were already taking a certain medication, they would continue taking that medication to see what the results look like. And then if we thought we had a treatment that was better than what they're already taking, we would change that treatment to the new treatment and then again observe, did that fix it or not? All right. And then, of course, there are advantages and disadvantages for experimental studies on why you would want to do it versus an observational study. So, advantages participants can be assigned randomly to treatment and control groups, and the independent variable can be manipulated. That's the advantage. I can literally pinpoint one variable, change it, and see if that change did anything to the data. Disadvantages, though, they often occur in laboratories or special classrooms rather than natural settings. So they call this the Hawthorne effect, where a phenomenon that occurs when participants' behavior changes because they are involved in an experimental study may occur. So there's a Hawthorne effect where because I'm in a lab or I went to the doctor, so I'm in a classroom, my results end up being better or worse just because of the atmosphere. So it could be an atmosphere thing, but that might not be what you were studying, right? You were studying a certain medication. So a variable known as a confounding or lurking variable that is not being studied, recorded, or manipulated may actually influence the outcome of the dependent variable. So another example could be, all right, if we're checking blood pressure, for the people that are, I don't know, more competitive, their blood pressure could be affected by how much they exercise, not for the fact that they're more competitive, less competitive, right? So it could be their diet. There's other co-founding variables that aren't being looked at that could actually be affected if we are manipulating competitiveness or just one little extra thing in there. Right? So, in the flip side of this, the advantages and disadvantages for observational studies. The advantages could be the study does occur in natural settings. So the study occurs in a natural setting. This type of study can be used when it would be unethical or dangerous to manipulate the independent variable, right? So it could be dangerous if we were to um, have less exercise or more exercise, or tell them to eat more fast food versus not eating more fast food. That could be dangerous to their health, but if they're naturally doing it, we could just observe that. We see that Joe eats out 3 times a day and he's eating fast food, 90% of the time. How is that affecting his blood pressure versus um, John is, eating out once a week and 50% of the time it happens to be fast food, right? What effect does that have? Well, instead of forcing people to do that, we can just naturally observe that and then just see what happens. Variables that cannot be manipulated because we cannot control anything. This is all stuff that's being observed, such as ethnicity or left or right handedness, can be studied. So again, we maybe blood pressure is affected by left or right handedness. Maybe blood pressure is affected by the ethnicity that you have. Maybe they just withstand more. It just things that you can't change, you can just observe in their natural setting. Now, disadvantages of this, cause and effect cannot be shown. We might have, hey, this right here results that they have low blood pressure, but it might have nothing to do with competitiveness. It might have to do with their eating habits or their work or anything like that. So studies may be more expensive and time consuming because you can't control the situation in a lab. Now you got to take a lot of time and find people and observe people in their natural habitat. So then results are subject to being inaccurate due to dependency on those who collect the data, right? So there could be the people collecting the data might be convenient sampling. Maybe they're asked to find, 40 people and their eating habits and see what they pay attention to, and they happen to live right next to a McDonald's. And then that's what they observe is people are going in and out of McDonald's versus someone that happens to live next to a fancy restaurant where they barely get any food, or a workout facility where they can see that they're always doing, protein shakes. Like things like that can skew data as well. So how the data is collected definitely can be skewing of your data that you're trying to collect, unless you want it to be that way. Keep in mind, though, that the two different studies regarding the same independent and dependent variables may result in different or conflicting results. This last one here is results. So I could study the same thing, one in a lab, one in nature, and get two different types of answers, where maybe I get vice versa. People with high competitiveness might have low blood pressure, right? It all depends on the variables that are hard to manipulate. In objective 7 here, we're going to explain how statistics can be used and misused. And I will say in our natural world here, statistics is usually misused all the time. Statisticians' jobs are usually to manipulate the data to make it look good for whoever they're working for. It's all truthful in a sense, but a lot of stuff is not observed or wrote in and not um, talked about just so that data could look good for others. So, statistical studies are sometimes reported in a way to sell products that do not work, prove something that the study did not address. Besides, statistical studies do not really prove anything, rather, they provide evidence to support or not support the premise. So, or engender fear, shock, or outrage people, right? Things that you see on the news is statistics, and it can really skew people where they go, oh, I better go buy all the milk at the store, or I better go buy a whole bunch of chicken eggs or chickens or whatever the concept might be. Statistics is being used to outrage or um, filter certain stuff to people to make it manipulate data down the road. So even though the results of statistical studies are reported, does not mean that results are reliable. All right. So a couple things to keep note of is the samples may have been too small, and this happens all the time, right? We see this on the news where it says one newscast whatever, it's close enough. Um, we'll say, 70% of the people like the president, and on the next newscast, 70% of the people don't like the president, or whatever the concept might be. And really, when you start really deep diving, the sample might have been 1,000 people to represent the entire country, right? And then out of those thousand of people, they might have been people pulled from a state that sees their same point of view, right? But the data will be there. It's all truthful data. It says, how is it pulled? How is it asked? That's another big thing, too. We can manipulate how the question's asked, where we can get real confused and we think we feel a certain way. So that's how we answer. But really, the way we answered it now makes us, on paper, believe the opposite of what we believe just because of the wording. So there's a lot of things that can get in there. The subjects may not have been selected randomly, right? A big one is just convenience. Um, People at my local grocery store, do you like the prices that we have of certain foods, right? That could be just convenience. And of course, they'll all probably say yes or no because we'll all have the same agreement. And then the last part here, too, the results may be misinterpreted. Let's take that very first thing we talked about in the first video. when we talked about the magazines or the comic books being bought by females was upticked. We saw that went from 40% one year to 53% the next year. Well, people could say, again, in the study, people said that, well, there's more women in comic books that make them more interested in buying it. But someone else could come back with the misinterpretation of, well, it's because men work. They don't have time to go buy comic books. So therefore they downticked and upticked on the females aspect, right? They can misinterpret it and skew the data towards whatever belief they want it to be. Still using the same data that that other person used, but then misinterpret it. So you got to definitely look at your facts and then come up with your own interpretation of those facts. What do you feel is happening? Right? If I only get a certain amount of people in a certain area, then I could be like, oh, well, here's the reason why, or whatever the concept might be, right? Another type of situation is the use of poor sampling methods. Again, the samples may not be large enough. Again, 1,000 people to tell us how our entire country's doing, not large enough, right? There should be at least 1 million, at least, right? That would be a better sample. The participants may be volunteers, perhaps with strong feelings for or against the premise, with a already built-in bias. If I want to know the opinion of your president and I say this is a random phone call, do you have time to tell me about your opinion? If I really don't care, I'm going to be like, I'm busy, and then just hang up. Versus someone that's like, oh, I hate how he does this, this, and this, or I love how he does this, 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 right? It's already biased versus someone that didn't have a care in it, just didn't do the survey. But it's really that data we needed too. That would skew the data back to normal. All right. Certain sections of population, such as those who work or even the elderly, may have been systematically excluded, right? If I'm doing a survey between Monday and Friday from 8 to 5, well, I'm not going to catch any of the working class. Or if I'm doing the studies at jobs. I'm not going to catch the elderly who are retired, right? It's very biased. It can be poorly sampled in that sense. Everybody has to have a chance to be part of the sample and have somebody in it. If I wanted to do a survey of people in this class and we ranged from people in as 18 to 60, I want to get someone in each little age group. So I have a word for everybody, at least some type of representation for that group. I don't need all 20 people that are 18 to 30 or all 20 people from 50 to 60, but two from each and then two in there in the middle, then we can get a good interpretation of where we're at, right? So those are those poor sample methods. And then of course, what we talked about already as well is the convenient sampling may have been used, such as intact classrooms. If I asked y'all if y'all enjoyed statistics, y'all either love it or hate it, versus someone I go ask in a an English class who will definitely hate it. Or I go ask a group of people or mathematicians, right? They're going to love statistics, right? All about that convenience sampling there. So watch out from where the data comes from. The data, what they show you on TV, and they say this is where the data came from, this is the data results. All right, that's truthful because it has to be. But then the interpretation of it will skew because they'll say, well, because the data says this, we can see that this is what's happening. You're just making an interpretation of that. So just watch out for things like that. Ambiguous averages as well. So several values, including the value that occurs most often, the middle value of an ordered list, the arithmetic average, or the mid-range average could be reported as the average or typical value. The average that lends the most evidence in support of the researcher's position is likely to be reported. So a couple of things here to think about as well. If I do a mean, median, mode, range, and all this stuff, these are all different types of averages you could technically use. Well, if my mean, which is a true average, is I don't know, 5.2, but I want to show that people's ratings of my class is higher up, and I see that my um, Mode is a 7. I just have a couple of ones that really skew my data down, but I'm like, I got a lot of sevens. I'm going to give 7 as my actual ambiguous average. It's truthful, but it doesn't really tell you the whole picture. That just happens to be the most used number, but really and truly 5.2 probably was the better number to choose from. But again, if I want to, show that up, then I definitely want to use that data. All right, then you have detached statistics, right? This is what you also see a lot of. This is one with no comparison is made. 95% of dentists recommend brand A toothpaste. This brand is recommended instead of what brand, right? We don't have anything to go with. We're like, so think of this. 95% of dentists recommend that you use Colgate toothpaste. Okay, over what other brands were there to choose from? The options for them could have been Colgate or nothing, right? So a lot of them were like, well, at least use something. The brand is recommended instead of what brand? Or do dentists recommend several brands, including branding? So there was a disconnect there. Cookie B has fewer calories. Fewer calories than what? Right? Than it used to have, or another brand, right? Are we just saying, wow, this one cookie has 300 calories? It used to be 320 versus, my double chocolate caramel fudge cookie is has fewer calories than a complete sugar bar, right? It has to have more to it. These are detached statistics to make you think, hey, this is really good for me, or this will probably taste good because dentists recommend it. Well, do you have all the data to declare that? So things to watch out for when you're looking things on the news and on TV for commercials and stuff like that. Other types of misuses can be implied connections. It's a big one. We can imply something by what we see, but that could be our own interpretation. Use words such as may help, right? This toothpaste may help your teeth become whiter, right? You might go, oh, good, I need this toothpaste, it's going to be whiter, but it may help you. The people that we saw, it did get wider for 2 out of 20 people. So it may be you're the 5%, right? So it's implied connections. And then that causes this misleading graphs, right? I can come up here and I can be like, or this, not a pie chart, but this one's a good one. And I love seeing this one. They'll be like, here's what people feel by the love cookies, right? Love cookies versus broccoli, right? They'll be like, all right, we love, look how many people love cookies. Cookies must be good for you, right? Misleading, right? Bar charts, circle pie charts, histograms, all kinds of different things, misleading graphs to make it look good for them. Or they could say chocolate cookies here, right? Everyone loves chocolate cookies, and over here, other cookie. What other cookie? This cookie could be a broccoli cookie, right? And it's just misleading graphs. Faulty survey questions. Again, how questions are phrased is huge, right? I don't know if y'all vote yet, but sometimes when we vote for a proposition, the way it's worded, we're like, well, I don't want my tax to go up, so I'll say no. But the way it was worded was, well, if you don't want it, you should say yes. And then we just said no. So that means now we want our taxes to go up, right? So it's surveys are the same way. It's all about how it is used. All right.